Okay, so we want to go here and open a new tab, and that should take me to the Cloud Compiler. It's the same example that we had done in Visual Studio Code. So we went to, let me see if I can do this so that at least this is larger, the code, so y'all can see that. Maybe make this smaller after I open the file. So I want to go to SRC examples, and I can't see. It was this guy. And then we want to write some code here. It'll be the same code. So we simply want to create a function that returns an integer. This is vars.h, commonly known as a header file, right? So in our header file, we simply write int, meaning that's the return type, and then echo variable. I didn't know that I wanted to do that. I guess because of, oh, that's pretty smart editor. Okay, int, and then num, and then again, notice we only put the function signature or prototype, right? So all of this together here is a function prototype or signature. And notice that we have a semicolon there. And that's the only time that we do that for functions, right, in the header file. And we are doing this as a promise to the compiler that we will write code for the echo variable function before we try to compile. And we do that in the vars.cpp. So let me make sure that at the top, the first thing I have to do is help the compiler. So I help the compiler by including vars.h. I don't think I need to do that. Let me try it without this. Because it's in the same folder, right? So so it should find it. Okay. Control V. So notice I copy everything but the semicolon. Open, close curly brace. And this function simply will return the num. So notice here we have an integer parameter named num. We say we want to return an integer, so there we go, right? So num is an integer, so we are returning an integer. We kept our promise, we wrote code, and now we can go ahead and write a test case. So we have to go to test. So the test folder, examples, and we come here, and we go ahead and change this to vars. And here I write the test case, but let me copy this function, right? So the test case function. And then we learn that we have to have a different name, right? Otherwise, none of the test cases run. So verify echo variable. We can just put like an explanation, should return param value. And here we can call that echo variable function. And since we're just returning the same value, then we know that it should return 5. So that's what we are saying. When we call the function echo variable and we pass in a function argument of value 5, then it should return the number 5. So we have our code ready, but now we need to compile and we need to run the test case, right? So what we will do is get the test case name. So ex01 test. Okay, so it's always in that executable function. Okay, and it's always the first parameter. So Control C. And then I have to go to the Replit file. And the first guy I need to change is this one. And now I have to help the operating system find this file. Okay, so I want to run this file. And this file is in test, so I have to change this from src to test, and then examples underscore test, so examples underscore test, 01 module test, and then that's it, right? So then we can remove the hello world piece. So this should tell the compiler, like after you, the operating system, after you run all these commands and then move into this folder, and in that folder you will find this executable, go ahead and run it. Okay, that's what that means. So let me go ahead and make this larger so we can see what will happen, okay? So let me test example underscore 10. I'm just verifying, make sure I didn't mess up. PWD, Art Gonzalez, okay. So let's hit run here and let's see. So it's building all my programs, right? But it'll only build them one time, so then it'll take about 2 minutes here. From here on going forward, like it'll detect that it's already compiled the program, so it'll only compile programs where I've made code changes, okay? And I'll talk about CMake in a little bit. Let me see here. So we're talking about Cloud Compiler. I'll give you all a GitHub overview, show you more or less how GitHub works, upload, download, and then eventually I'll show you like what CMake helps us with in our coding, okay? Yeah, I'll make sure. I know there's a lot of tools, and I'm pretty sure you all are like, wait, in Python, it was so easy. So that's why I'm taking the time to make sure that I at least cover the tools that you all are going to be using. Okay, so it is a free service, this Replit compiler, so they don't give us a fast virtual machine, right? So I'm pretty sure I think we're lucky if they give us 4 gigabytes of RAM. Maybe we have like 2, so they don't give us a lot of memory. And we probably share this virtual machine with a lot of other Replit users. Let's see if there's any questions. No, so this, if you're using Visual Studio Code, then this is, I guess, irrelevant. But I want to make sure that I go over at least one demo of Visual Studio Code and then do the same one in the Cloud Compiler. But mostly for the semester, I usually use Visual Studio Code. But if students are like, hey, show us some examples on the Cloud Compiler, then maybe like I can alternate. The code is the code, right? So. And it's at 92%. I'm still thinking. Yeah, so middleware, right? So that the back end middleware. Mm-hmm. Yeah. Mm-hmm. Yeah. I should be there. Let me switch to Visual Studio here. Let me drag it back over here. Let me close this. So let me close it. Usually it's very user friendly. Like here in recent, you should see it. Yeah. Yeah. It should be here in recent, and then you just click on the one that has your username, and then the code will be there. Mhm. Yep. Okay. Yep. Mhm. Yep. I guess while this is well, 98%. That's oh, it's gonna finish. Okay. Man, I did. Yes, in yesterday's class, this ran a lot faster. It was like at 94 for a while, and then at 96, and at 98, and then it's at 99, and it's just yeah, it's just taking its time. Okay, so notice that all my tests passed, so which is good. Um, and if we want to, I should have done that. Space dash S, right? Forgot that. So that it can show me details. It should be a lot faster right now. Because you should detect that it's already created the executables, and then it runs a lot faster the second time. So notice this is what we saw in the previous class, right? But in Visual Studios. But now we're looking at the same thing on the Cloud Compiler. Let me make this a little larger. So if you are using the Cloud Compiler, notice that it's the same thing, really. The only thing that some students get confused with is the CD, these two options here, right? So notice here, this is to run the test cases, but now the next question that someone who's using a cloud compiler should be, well, how do I run the main program, right? And what is the main program? And we come over here, and SRC examples. Notice that the way of structured programs is like at least one header file, one CPP, or commonly known as implementation file, and then a main.cpp. This does not have to be named main.cpp, but just for my help and just so that my eyes can be like, okay, this is where my program is going to begin, right? That's why I just do main.cpp. So we have the vars.h, we created this function, and we added the function code. We've already tested it. It passed. Now we can use it in our program. And why is this important? Well, I mean, we only want to use code that we're confident in, right? Or that we tested. So we tested, I mean, I know it's an easy function. We're just returning a value. But my thing here, I just want to show you the process that you need to follow to be successful in this class. So we want to display something. That means include the IOStream header. And we've been doing this, stud cout. But if I have to do a lot of couts, notice that my arms are gonna be like hurting, right? So if you read the book, the book recommends using namespace std. Don't do this, please, especially if you want to go into the industry, right, and be a programmer. Instead, we can say, well, we will use that using statement, but I'll say using stud cout. So once I reference that at the top, then in here I can simply say cout. Echo variable 5. Up here, I need to help it, right? So include vars.h. That'll give me access to this function, okay? And maybe I want to say value is. So notice now, like if I have a lot of couts, then I don't have to do the stud cout. So, you know, then it kind of makes the code very difficult to read. So am I the one that is recommending this? Because I want to know this is how the industry does it, right? So that's why I recommend this. And think about it as a professional programmer, right? So if a programmer comes in here and has a list of using statements here, like one or more, maybe like 5, then that programmer can immediately get a picture of how the standard library or other libraries are being used in the program, right? So if you do the book method using namespace stud, and there's more than one line, maybe there's like 20 lines of code here, 30. Using namespace stud only tells me that I'm using the standard library, but it doesn't tell me what objects I'm using. Then I have to go and read 30 lines of code. But if I can reduce that to maybe 4 or 5 lines of code and get a picture of what's going on, then obviously I want to do that, right? So this is the way I recommend you do in this class. Okay, so we should be able to run this, but we have to change the Replit file, right? So we have to come in here, CMake list to get the executable name. It's always under the add executable function. So it's this guy right here, Control C. And then I can come into the Replit file, and then I can remove the space -s and this file name, everything except the ./, okay? And now I also have to change directory into the correct folder. So I come here, src, so this one becomes src, and remove _test, remove _test, and then 02 int. So now I'm telling the operating system, change into this folder or directory, and in there, execute this file. So that's what we will do. Okay, so let me make this larger. And then run it. It should only compile that program I changed, and everything else is going to know that it compiled already, so it'll skip it. So notice how fast it is. And if I move this down here, notice value is 5. And that's how we can use the cloud compiler. I like the cloud compiler because you don't have to install anything. And then you kind of get experience a little bit with the command line, right? So yeah, so other than helping our vision, right? So the question is, I mean, what is it? I mean, do we get any benefit from using std_cout or just using namespace stud, right? So that goes back to that example where I showed you where there might be different cout objects. Maybe somebody created, hypothetically, my IOStream, and then they also have cout, right? So if we just use using namespace, then our compiler gets confused, right? That's the first thing, because when we do this, then we're making the whole standard library objects that are in the IOStream header available. And then if we have other standard library includes here, then we are polluting or causing potential issues in the future, right? Because maybe we have a cout and then another cout, and one cout is here and one cout is over here. So then it's kind of like the compiler is going to be like, which cout, right? So that's why. Yeah, the compilers nowadays, they're smart enough to only create or include code that we absolutely need. So this would be more like library conflicts that would get us. So let me remove this and let me go back to, oops, maybe like 20 years ago, right? The compilers wouldn't be as smart, and then we would get large, very large executables. But nowadays, they're actually pretty good. Okay, so any questions so far? Yep, we only want to import what we want, what we're going to use, right? And then if you import something that you use, and then you remove that code later on that doesn't include need that include, then remove it, right? Because it it makes reading the code easier, but then the fewer lines of code we have, then the easier it is for us to maintain the program, right? So, okay, so now let me go back here. So we did this, and now we want to, what is GitHub, right? So we come here, and everyone hopefully by now created a GitHub account and has their cloud space on the GitHub website. Notice that we have some files here. We have the inc include catch.hpp. So this is the unit test framework. I don't think we want to look at the code. Oh, I guess it came up. Because, I mean, it doesn't really make sense for me to show you the code, right? But somebody put in a lot of work so that we can have a nice, easy to use test framework to test our code in C++, right? So that's inc means include, and we only have one include, the catch.hpp, and that's where you would put external include files, right? SRC stands for our main source code. We'll use the classwork as homework assignments once in a while, and what's in here follows the same pattern. You'll always have a CMake list, you have a main.cpp, and then a header and an implementation file, okay? And the same thing for examples, like these are the examples I'll be working on throughout the semester. And all of them follow more or less the same convention, like header, CPP, CMake list, and then a main.cpp. And for the most part, all of them have a matching test folder, okay? So let me go back to the source folder, and then we have the homework folder. Okay, homework folder here. Notice you'll be having homework for variables, expressions, decisions, iteration, vectors, which are lists, and then you'll have the tic-tac-toe assignment, and that'll take about 4 to 6 weeks to complete, right? And different homework assignments. Okay, so come back here to, and then you more or less see the same folder structure in test, but they're preceded by underscore test, and this is usually how you'll see, like in programming shops, you'll see like classwork underscore test. That way there's no confusion, right? And how is this one structured? There's usually a implementation file, and notice there's no header file. So in this, we don't need a header file. Instead, we just implement functions, and all these functions use this test case. All these test cases use this test case function, right? And then we have a CMake list that has code or script to create an executable, and then notice that we link some code. So this library, if you see here, where are we? We're in classwork test, right? So where did this guy come from? So remember, test has a matching folder for source. So if we come to SRC here, and this will be the case for all our assignments. We create a library, CW01 library. And remember, I said a library, it just is compiled code. You cannot run it, but you can use an executable to link to that library and then call functions that exist in that library. That's in essence what we're doing when we let me open the Hello World program. Thought it would be faster here, but I didn't have it open. So that's in essence what's been done when we say cout. Cout is in a library. So when it compiles, then that IOStream library is linked to our executable, the Hello World executable. And that's how when stud cout statement runs, then it goes into that library and finds the cout object and calls that, and then that object has code that knows how to display hello world to screen, okay? So what else in GitHub? Yeah, so the purpose of different header files is that you seldom will you, so it's mainly to show you program methodology that scales from small programs to industry standard large programs. Okay, yeah, Clang instead of GCC. Yeah. So and it has so usually, like, as our program grows, then we want to group like functions together into modules, right? So maybe we have like the accounts payable header file, the accounts receivable header file, the payroll header file. And that way for humans, it's kind of like, oh, okay. So, and then we write the code in the appropriate CPP file, and notice that scales to like industry large, like millions and millions of lines of codes of C++ code programs, right? So that's why I do that. That way, when if you go work, whether it is for C++, C Sharp, Java, then you're used to adding modules for your code, and your coworkers will appreciate you for that, right? That's as opposed to writing the program in one file, because if you do that, number one, it's hard to maintain. Number two, they're gonna frown at you and be like, "Hey, who was your professor?" You know, or where did you learn that, right? So that's why I teach this way, because that's how the industry programs in C++ and C Sharp and Java and Python too, believe it or not. Okay, Clang should work. I think we are using Clang here in. Let me see, where is the Replit guy? So let me come here, Replit. So notice compiler, Clang, compiler, Clang. So Clang should work. I mean, you just saw it work here. We don't use GCC in the Replit compiler because it was freezing. Like the virtual machine would freeze. So then after some research, I found out that the Clang compiler works. So then that's why you see all those command lines. But in our computer, on Visual Studio Code, then we use GCC. Okay. Okay. So I'm going back to GitHub. So our code is here, but then we have a copy of code here. Okay. And this guy here keeps a history or breadcrumbs of how our code changes over time. So if we come here and if you look at this right here, 5 commits. So if I click on 5 commits, then it shows me a list of commits that I've made since I opened this repository. This initial commit is when GitHub copies the code from the starter repository into this folder. And then I modified some Replit settings. And if I want to know what they were, then I can click on this link. And on the left side is what was there before, and then the right side is what was there after the commit, right? Then I can go back, add online IDE URL, and then I'm like, well, I don't remember what that was. Then I can still come here, and then I'm like, okay, so what changed here? Okay, so before using the Cloud Compiler, it was like this, but then I wanted to add the working Replit icon. Which one? This one, right? So I had to make a change to README to add this gadget, and then it was there, and then I committed. Okay. So as you turn in assignments, your commit list will grow. Okay. And especially when you get into the tic-tac-toe application, then you'll appreciate how GitHub keeps track of homework tic-tac-toe 1, and then you can see how it grows in tic-tac-toe 2, 3, 4, and 5, right? So you can see like how development shops in the industry work for you. Yeah. And what else here? So usually your latest change will be next to your name, right? So this was my latest change, and you can just click on it, and then it'll show you what you changed. But I don't know, setting up GitHub Classroom feedback. Well, there was no change there. Also, what is this guy for? You can go to your repository back in time to how it was before you made any changes. So if I right click and go to open, then notice I don't have I only have one commit, right? So in essence, you go back to a snapshot in time of your repository. Sometimes like when there's bugs, then they have to do that, right? And when did the bug start? Started here. Okay, let's go one more version back and see what happened, right? So, questions so far? So in some of the student reviews, I don't understand students sometimes, right? Like they use GitHub the whole semester, and then in the review they're like, I don't know what GitHub was for. I was like, oh, okay. So I mean, even though I tell them what it's for, but for some reason I guess they checked out during that lecture. So I'm making sure that I go over it to make sure that everybody understands, you know, like what it's for. Okay, so what else in GitHub? So pull request. So when you submit assignments, then I'll give feedback, and you'll get an email, and then you click on the link, and it'll take you to a page where I have some feedback for your code. Okay. It's hard to demonstrate now, but once you get the email, then it just says go see the change, go see the comment, or go see the the guidance, and then you follow the link, and it'll bring you to a page like this, and then you can see like my recommendation for your code. Okay, think that's it for overview of how GitHub helps you track code, right? Okay, we had made some code changes on yeah. So here, yeah, here you're only responsible for your code. Let me go back here to intro. Nobody else is going into your repository and making changes. Let me see, development methodology. Like only you have access to the main source code. In a team, there can be one or more developers, right? So here it's you, but there might be like maybe 3 developers, 4 or 5, maybe 10. All of them following this code, test, read, fix. Once it's green, use in main. Then afterward, you can upload to GitHub. Always the goal is to upload working code to GitHub. You get in that good habit, then when you go work in a team environment, then you'll be like, oh, okay, my code has to be tested with unit test. I gotta run the program on my machine, make sure it works. Somebody will review with me who's more experienced than me, and then they'll give me the okay to send that on to the source code repository. And GitHub right now is like the number one source control software in the world, right? So you came to the right place. So okay, so next topic. Let me see here. Talking about GitHub, so now maybe upload some stuff to GitHub, right? So hi overview. Okay, we did this. So show upload from VS Code to GitHub. Okay, so let me come here and our Gonzalez ACC. Okay, so I made some changes, and notice right here I have 4, right? So I'm like, oh, what's this guy? So I click on it, and the Visual Studio Code is linked with Git, and Git you installed, and Git is a utility that works with Visual Studio Code to send and download source code from GitHub. So now here it's telling me you have code that's different from what you have on the cloud. So now I'm like, oh, okay, so maybe I should upload it, right? So let me see here. How did this one change? See? So I had nothing, and then this is how it looks like now. And then if I go here, then notice on the left side what I had and what I have now. And then I can go look at my test file, and then what I had, what I have now. So usually it's very good at like helping you visualize and see real quick like what you're changing, right? So now I'm like, okay, so I can I did them in the previous class. Yeah, yeah, I changed them. These were examples I went over in the previous class on Tuesday. Yep. I didn't upload, right, because I usually like to break stuff down, make sure that everyone's following me. So, okay, so example one, int test int function, something like that, right? So then I'm like, okay, so let me go ahead and so if you notice, I get the same plus sign here, 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 here. So if I only want to upload one file, then I go here. But I'm 100% sure that all these 4 files belong together. The change belongs together, right? So then I can just go up here to changes and then say, okay, I want to stage my changes. So then it gets them ready. And then I want to commit my changes. So remember, let's go back here. Development process. GitHub has the main source code, but we have a copy of the source code. When I click the check mark, it updates my local copy and gets it ready to send to GitHub, okay? So I know it's ready, so now I need to click on these 3 dots and hit push. Once I hit push, then it's going to send my changes to the cloud, okay? And this is how you turn in assignments, okay? So you have to stage, commit, and push. That way I can download your source code and check your grade your assignments. Okay, so we go back to GitHub, and then we go ahead and hit refresh here. And I think I'm in the wrong repository. Let me see here. I have 2 Art Gonzalez's, one for, I don't know, it was this one. So let me follow this link. Okay, so let me refresh this one. Maybe this is, no, this is the wrong one. Okay, so I followed the correct link. And notice here, example 01 test int function. So if I click on it, then I can come here and remember what I was showing you in Visual Studio Code, how each file was before and after the commit. So now I get the same thing, but on the web, right? So main.cpp had this code here, and after I went over the example for the previous class and on Tuesday, this is what I changed it to, what I had, what I changed it to, what I had, what I changed it to. My test case simply had a one test case, and then I added another test case for the echo variable, right? So that sends the change, and notice now I have 6 commits. So if I click there, now notice January 28th, then I have that commit that I just did a few minutes ago. It works the same for the cloud compiler. Let me come here. So in the cloud compiler, notice there's that version control. And you would go here, type a comment, and then hit commit and push. And it would send you changes from the cloud compiler website to GitHub, right? So So how does this work? Your working copy of the source code is on the cloud compiler. You access it through your internet browser. When you want to commit, then you're sending, not from your computer, but from the cloud compiler to GitHub. And when you want to bring down data, then you get it from GitHub onto the cloud compiler, and you access it via the browser. Okay. Questions? I'm gonna be, so, oh, where's my pen? So in here, well, I'll go to GitHub, okay. So in GitHub, you'll have, oops, what's going on here? You'll have your main copy. That's fine, that's fine. You don't have to apologize. So that's your copy, and then there's a professor copy. So I'll be modifying this in the feedback. I'll be modifying this, and if you want to merge, I'll show you how to do that next week. My changes, then you can put them onto your code. So I don't go in there and update your code. Right? It's up to you if you want to merge it into your code. I'll go over that in the next class. Yep, and that's a good point. So from now on, every time you open GitHub, I mean Visual Studio Code, and then it opens your project, before you do anything else, then go to the version control, click on these three dots, and do a pull. Make it a habit, right? Because right now you're just working by yourself. But if you're in a team environment, every day there's changes going into the repository, right? That won't happen in your case, but just get into that habit that if there's anything here, you want to bring it down to your computer. And if you do that, you'll always be up to date locally and on the cloud. Yep. Yeah, just pull right here. Yeah, you don't have to worry about any of no, don't just push and pull. You know, we keep it simple. Yeah. Yeah, so usually like when you open Visual Studio Code, you see this and you click on this source control icon right here. And then you click on these three dots here and then you do a push. I mean a pull, right? Like if you want to bring stuff down, then you pull. If you want to send something, then you have to push. Mhm. But before you push, remember you have to uh, stage the change, commit the change, and then push it, right? And if you forget, then you can just, I'll upload this video to YouTube tonight. And as a matter of fact, let me show you where you'll see the lecture link. You'll see it here. I haven't added it yet, but there'll be right here. I'll put like video lectures, and then you follow it, and it'll take you to the YouTube list playlist. Okay. Okay. So if you're like, man, this is too basic, then just bear with me, okay? Like I want to make sure that everybody is on solid footing. So, okay. So where are we? Okay, CMake. So what is CMake? I'm kind of giving you a high-level explanation of what CMake is. It helps in the compile process, and then we only write one set of CMake script, and that'll work in Mac, Windows, and Linux. But it also helps with our source code, right? So I'm here, and if I go to SRC, And if I go to, for example, examples, and then I go here to SRC examples, and then I open the examples CMake. Notice this code, add subdirectory and 0, 1, 2, 3, 13 modules. So it's just a listing of these folders. And right now, the first three options do not have a pound sign. So the pound sign means treat it as a comment in the CMake scripting language. So right now I'm telling CMake, hey, for right now, just worry about compiling 0.1 module, 0.2 module, and 0.3 module in my examples folder. And that's okay. We can do this because usually, I mean, what we do to run our apps is here, right? And even if there's like 100 million apps here, then if we know we want to run this one, then we just go here and then right click and run in terminal. It'll ignore everything else and only build and compile this piece of code and run it. Okay. In the cloud compiler, it may or may not make a difference, right? So I personally don't think it makes a difference because, as I showed you, the slow build is the first time, and then after that, it detects that there's no changes, so then it just skips those folders and doesn't try to compile the code again. But if you go here and go to the same folder, SRC examples, and then I open the CMake, then if I want to only worry about module 1, then I can do this. Like I can mute modules 2 through 13. And then when I hit run, then in these examples folders, it's only going to try to compile module 1. I kind of encourage students just to leave them open, and that's just to make sure that if you have programs that aren't working, it tells you. And that might be like a pain, but that'll get you into the habit of only having code that works, right? Like as your program grows, and if you have programs with errors and you're like, whatever, I'm just going to leave them there, then that's not good, right? Because then you're getting into the bad habit of keeping code that does not compile. So number one, always have code that compiles. If it becomes too much for you, where you're just like, there's too many errors, I can't keep track, then you can go in here and mute them. That way you won't be seeing the same errors come up every single time, right? The only problem is that if you decide to do this, say you decide to mute everything but number 1 here, then you have to make sure you go to test examples, CMake list, and then you have to disable 2 through 13 also. Because what happens when you compile a test case, say this one's not muted, then this test case is going to look for source examples module 2, but since we told the compiler not to build anything, then this is going to error out and it's going to tell us I can't find the library file for module 2. So they go in pairs. And the same applies for classwork and homework. The homework folder, oops, where is the homework folder for this one? And if I'm losing you, then you can always come back here and just kind of follow what I was saying, right? For now, we don't have to worry about this for like 3 weeks. We will have to worry about it if you're following along with me in about 3 weeks, right? Let me see what I have for the homework folder here. So homework, CMake. Yeah, so you see for the first few homeworks, you don't have to worry about it. Once you get into homework 4, you will have to go into your CMake list and open this one up for business. And you will have to go and do the same thing to the test homework folder. Not that one, this one. And you'll have to open this one for business, right? But I'm not gonna do it right now. I'll remind you all, and I put the help in the homework assignment just to remind you all that you have to unlock it. I tell you what to type in which files, okay? So that's how CMake works, right? Like it helps us also control which files are compiled and which ones are not. Okay, any questions? Let me see here. Okay, so for now, you don't have to worry about that, the CMake list files. Okay, so now let's see where we go now. Review dev process. I think what I want to show you here is how we write code again, right? So I know some students are like, hey, wait a minute. In Python, all I did was just have one file, and then I just started writing code. You know, I didn't have to worry about including anything, not till like the 5th week. And as long as I was writing code that belonged to, that I come up with, I just wrote everything in one file, at least not until the professor introduced me to modules. But in the industry, that's not how programmers work. Programmers always, let me see here. Recall the standard library has the core language and the library. And that's how coding is at its most efficient, right? So in our programs, we create our own libraries, our own libs, and then we have our main.cpp that uses those libraries. If you want me to show you briefly, right? So notice this int example that I did. We have the vars, and then we have vars.cpp. We look at the CMake, I'm telling it, hey, create a library from the vars files. Name it ex0102 library. So that's how we want to work. And this will make main smaller. And then we're just calling functions. Like we just call functions from the standard library or functions that we create. And in the future, classes or objects. Okay. Why do we do it like this? Because it's scalable, right? Just imagine, like right now, it seems like overkill because it's kind of like, man, this guy like he used three files, you know, and he has just like one function, and then he has like a function that only has one line of code. But that's just to kind of make it easy for you to follow how we do work here, right? And then this guy, like, he doesn't let me do anything in main until I write the test case. Well, I mean, you only want to use code that has been tested in your main program. So that's why we test the code first. After we test it, then we come back and use it in main. Here, I mean, all we did was call it, but it hopefully it drills the point home. Okay, so let me get total. Okay, so integer get total has a unit, and then it has a double. So a double is a very large question. No, no, we create a library. So right now what I'm doing is I'm going to create another library. I'm going to create a library input, right? Look, yeah. So I'm going to create this library, ex0103, with files input.cpp and input.h. What does this library have? It'll have one function, get total. Integers are whole numbers. I'll get into detail in the next class, right? Double is a decimal number. It can be like a very large number, and it can hold very large precision, okay? So then this is just the header, so I just write the function prototype or signature. I come back to the CPP. I'm like, okay, I know I have to include input.h. That gives me access to the header file, and now I can write code for this guy. And what am I saying here? Function get total returns a product of parameters, units, and rates. Okay, so return units times rate. That's all we're doing here. So now I've created a library, and now main can use it, but also my test case can use it. Okay, so that's what we're doing here. Like I have this code, I mean, nothing stops me from coming here and using it. But I want to get into the habit of not using functions, not until I test them. So then I come back here, go here, and come here, create a test case here. So what do I need to do? I need to include input. Why? To help the compiler find my function, right? So input.h. So now get total is accessible here. I will copy this, open close curly brace, and verify the get total function. Should return the product of parameters, right? Okay, so that's a test case. Now we write an assertion with require. So if we were going to use that function in main, let me come back here. I would go here and go to main, and then I would include input.h at the top, and then I can use it here, right? I can use it. Nothing's stopping me. But before I do that, I want to test it. So get total, I guess 5 and 6, right? 5 and 6. So the product of that one should be 30. And I can go to CMake and go to test, examples test, and then run in terminal. And it's building. So when you do your homework, follow this pattern. You forgot the pattern? Go to the YouTube video and just go to the time in the video where I start writing this code, and that way you can do the same thing for your homework. It's like I said, the first few assignments are very easy. They're simple functions, and it's mainly just to get you comfortable with test cases, C++, and our development methodology. Okay, so sooner or later it'll finish. Linking. Well, yeah, well, usually, like if it's a payroll function, then like you have hours and pay rate, and usually you can come up with those hours, and then the testing team down the road, they'll have their own test data that they use. But yes, this, I mean, I know that 5 and 6 return 30, right? So, and this is my function, so I know this should be true, and it does pass. Notice up arrow space dash s enter. 30 is equal to 30, and then I'm like, you see, and then I'm like, okay, so let me. I'm not really. Yeah, like for example, here we do 5, 10, and I just kind of like make a mistake, and I'm like, well, okay, 15. So then I run the test case. So we're testing this get total. You can do this in main, like you did in Python. You can do it. Like there's nothing stopping you from doing it, and you're probably saying, sir, it'll probably be faster to do it in main. Maybe initially, but as our code grows, notice we have a function echo variable. Now we have a function get total, and we can add different test cases. So we're creating the test bank for our code. It's easier to keep track of, but faster to run. Like we just have to right click and run, and it'll run. Like if we have 100 test cases, it'll run them a lot faster than you can go in there and type 100 different data types for your functions. Okay, linking. Both functions as in this one and this one, or this two? Yeah, echo variable. Yeah, because we all of them are in the same test case, right? So notice it failed, right? Because 5 times 10 is not 15. Then I can come here and I'm like, oh, what happened, right? If we see that this is correct, then we would go into the get total function and fix our code there, and then run the test case again. But we know I purposely made it fail, so then I can correct it and then run it again, and it'll run the test case and it'll pass. Once this passes, then I'm comfortable and confident that I can use it in main. Yep, that'll be very helpful when you do your tic-tac-toe application, because for that one we create like about 200 assertions. It's like 25 test cases, but you gotta test different, like did I win by row, by column, first row, so you gotta test all those. So you're creating your bank of your test case bank, and then by the end of the assignment you have like 200 assertions, and your program will work, right? Because you've tested it and verified that it can work. Usually even students who are struggling, right? Like they get it done. I mean, they either come to my office hour, or they collaborate with other students, and eventually they get it. Yeah, so notice everything passed. So then I can go up arrow space dash S enter. So now I'm okay. You see 50, and then oops, 30. Yes, go ahead. Yeah, it's a command line parameter that Catch knows. It's like, oh, you want to see details, right? So that's all it is. Yep. Mm-hmm. It might be confusing initially, but after 2, 3, 4 weeks, it's kind of like, okay, I know more or less what I'm. You're also getting practice with working with a large code base. Hmm? Yeah, everything's set up for you. All you have to do is follow the steps. Like you don't have to worry about CMake or how do I compile. I mean, you just go right here and boom. Okay, so now we can go back to main in our input, and now we're saying, okay, what do I want to do? Capture units and rate values from keyboard. Okay, so include IOStream and write a namespace using statement. So I know I'm gonna need to output something, and then I need to input. So now I'm going to use character out or C out and character in C in. And then here I'm like, okay, capture units and rate values from keyboard, call it. Okay, so I need an integer for units. That's a variable. We declare it. Notice that we don't have to assign a value to it, unlike Python, right? And then double rate. So I create a decimal number named rate. And then I'm like, okay, so capture units. Okay, so I can say C out, enter units. And then I'm like, okay, capture input. and the keyboard number that the user gives me, put it in units. So notice now you have greater than sign. So from the cin, save it into the units variable. And this is opposite. We're going out to screen. So get this enter units, put it in cout, and cout will send it out to the screen, right? And then we're like, okay, let's do another cout and enter rate, capture input, and get the keyboard value, stuff it into rate. And okay, save the total to a variable name total. Okay, so we can say double, or are we turning integer? I think integer, right? So should have done double, but oh well. Integer total equals, so I'm going to call the function get total. I'm going to use this units and this rate. I'm going to call the function. The function is going to execute. It'll multiply units times rate and return its value as an integer. I'll save the value into total, and then I can do cout. Total is total. And I've created a program that will allow me to capture some data and output it, feed it to the function, and then get the function return value, and then output the total. I can go to this, yes. No, that doesn't matter. Just coincidence that these guys are, it's just coincidence that they're the same name. Yep, like if we say units, then it's first, and we need to put units and rate, right? So then we should be able to go to CMake here, examples. Yep. I think it's manage color theme. So right here in the gear and then color theme. And then you should be able to select like dark theme or light theme. Let me see. Yeah, you see you can select different themes. I have the dark plus theme. .cpp. I can help you in a little bit. Okay, so let me just finish this. So run in terminal. Scroll down. Enter units, right? Enter units, 10. Enter rate, 10. Total is 100. So there's our